Good afternoon. My name is Paul DelSignore. I'm the Deputy Chief Engineer of Structures at Amtrak. And this afternoon, I'd like to talk to you about some proposed major bridge and tunnel initiatives that Amtrak has planned with our own funding we have with some of our partners, and with the pending infrastructure bill that we're hopeful to receive. A little bit about our inventory at Amtrak. Basically, we own the Northeast Corridor from Washington to Boston, some assets in Michigan and Chicago and some other places, but for the most part, our assets are the Northeast Corridor and the spines coming off the corridor. Fixed bridges, we have about 1,327, average age 100 years old. Several movable bridges, most of them being over 100 years old, and about 18.6 miles of tunnel on the corridor, with the Baltimore Tunnel being the oldest, dating back to the 1870s. Some of the projects I'd like to talk to you this afternoon about, going from the north to the south. The first one here in Connecticut, the Connecticut River Bridge in Old Saybrook, Connecticut. Multi-span approaches and a lift span to allow for river navigation. Original bridge was built in 1907. 2-track, 10 spans, open deck, approximately 1,500 feet. The movable span is 160-foot long Scherzer rolling lift. Navigation channel is about 150 feet wide, and the clearance with the bridge closed is about 18 feet over mean high water. Many alternatives were studied. The bridge now is in final design. Design should finish up at the end of this year, this calendar year, and we are in the procurement phase next year, with hopeful construction in 23 if all of our funding comes into place. Some of the alternatives that were studied were the top depiction here is a bascule bridge with some truss spans on the approach. What we've decided to do is a hybrid of these two designs. We are going to have a bascule truss span as the movable span of the new bridge, but as the bottom picture depicts, even though it's a lift bridge with deck girder approach spans, the new bridge will have the deck girder approach spans and a bascule as the lift span. So it's kind of a hybrid of these two depictions here. Conceptual engineering was started in 2007. NEPA process has been complete. Received our FONSI in 2017. Final design and permitting is ongoing. We plan to procure the bridge in 2022 with a hopeful start of 2023 and a 4 to 5 year construction period. The next series of projects I'd like to talk about is our very important Gateway project. Takes place between New Jersey and New York. Everything either begins or ends at our New York Penn Station, and the projects take you west all the way to Newark, New Jersey. Several projects planned, several projects underway, but it's a multi-billion-dollar program to bring these structures into the next century. The hallmark of the project, of course, is the Gateway Hudson River tunnels under what we call the North River. It's the Hudson River. Presently, we have a 2-track, 2 single bores going underneath the river there, built in 1910, approximately 2.5 miles each, 450 trains per day. It's about 200,000 daily passengers between Amtrak and New Jersey Transit. Heavily used, limited work windows. And it's the only Northeast Corridor connection between New York and New Jersey. The new tunnel will add capacity to the corridor by adding 2 new tunnels. So we would have a total of 4 tracks, adding a great amount of capacity to the corridor. Next project that is sort of underway is our Portal Bridge project. The current Portal Bridge is a movable bridge that's beyond its useful life. Been subject to many delays and many commuter delays and a lot of complaints. We have received funding and coordination with New Jersey Transit and FTA and other partners that we now have a full funding agreement to replace the bridge with a high-level bridge. Anticipated start of construction is going to be spring of this year. A contractor was selected here just this past month in October. Other projects in New Jersey include the Sawtooth bridges, two bridges that traverse over other railroads. These two structures are beyond their useful life, hopefully be replaced. Harrison Fourth Track is a project to add another track in the Newark area to increase our capacity, and then rehabilitation of our dock bridge. So we go further south down the corridor. Next major project would be our Susquehanna River Bridge, a two-track swing bridge in the town of Havre de Grace and between Perryville and Havre de Grace, Maryland. The existing bridge is pictured up top here. It's 17 approach spans with a single truss swing span. The new bridge will be a high-level bridge, eliminating the need for a swing, and it would be a network tied arch similar to our portal span, indicating another signature bridge. Some of the highlights of the project are we're increasing the speed from 90 miles an hour to 180 miles an hour. The height clearance will be a fixed bridge at 50 feet. Horizontal clearance of the channel will be over 100 feet. And we'll probably be building this thing in phases. We'll replace the existing bridge with a new two-track bridge, demolish the existing bridge, and then phase in the second two-track bridge. Here's a close-up rendering of the network tied arch, and then on the right-hand side, might be a little difficult to see, but the phasing of the construction of erecting the first bridge, demolishing it, and then adding the second bridge. Final project I'd like to talk about today is our B&P Tunnel replacement. Our B&P Tunnel is just outside of Baltimore, Maryland, on the route towards Washington, D.C. As mentioned earlier, it's a fairly old tunnel built in 1870, a single bore, two-track tunnel. Some of the highlights of this project are much increased capacity, going from 35 miles an hour to potentially 100 miles an hour within the tunnel. The grade in this tunnel will be approximately 1.75, and initially we've studied building a four-track tunnel. Here again, we're going to phase it in two separate constructions, building a two-track tunnel initially to replace the existing, and then as funding and capacity is required, erect another two-track tunnel. This drawing depicts the existing tunnel in red, kind of not a straight alignment. That's why the speed is such at 35. The line in purple represents the alignment of the new tunnel. It's a more circular route. We call it the Great Circle route, but because we can make it such a large radius circle, we can increase speed and make it a smoother ride and increase our efficiencies. Thank you, and if there's time for questions, I'd be more than glad to entertain them.